So now let's do one last thing here. We know how the phase shift works, so the next order of business right here is to handle a vertical shift. What's going to happen when we start shifting our graph vertically upward or downward? Well, the only thing that's really going to change is the vertical position. And our vertical shift right here, in this case, means that whatever our graph would have looked like if it was on the x-axis is going to be shifted upward by 3. Now this does have a few changes. Let's go through the laundry list of material right here. Right now we know that our amplitude is going to be equal to the absolute value of 2. Well, that's just 2. It's a positive number, so there's no reflection. Our period will be equal to 2 pi. Well, 2 pi over 1, right, because there's nothing other than 1 in front of x. So our period is 2 pi. And by the way, that means that the key points within one cycle are at 1/4 of the period apart. 1/4 of 2 pi is equal to pi over 2 apart. But there is a phase shift. And in this case, that phase shift, if we set x plus pi over 3 equal to 0 and solve for x, we're at negative pi over 3, which is to say we're going to shift pi over 3 to the left. It's supposed to say left, pi over 3. Trust me, it says left. Use your imagination. All right, so what do we do now? Well, for one thing, our x values can be handled in the way that we've been handling them all along, which is to say we make our starting point, instead of 0, our phase shift of negative pi over 3, and start adding increments of pi over 2. Now this is going to be a little bit different because we have the denominators don't match. So let's rewrite it. If I wanted to add negative pi over 3 to pi over 2, I'm going to have to get a common denominator of 6. So we call this negative 2 pi over 6, and we're going to be adding 3 pi over 6. So the increment that we're going to be adding are 3 pi over 6 is right here, and our first key point is going to be at positive pi over 6. Now, if we go on by adding increments of 3 pi over 6, here's what's happened. I'm just going to write these in unreduced format. Pi over 6 plus 3 pi over 6 more is 4 pi over 6. Plus 3 pi over 6 more is 7 pi over 6. Plus 3 pi over 6 more is 10 pi over 6. So when we're using these values in our table, we're going to reduce them. So we're going to have 2 pi over 3 as another key point right here. 7 pi over 6 does not reduce, so we're going to keep it 7 pi over 6. But 10 pi over 6 will reduce to 5 pi over 3, and that will be the end of one full cycle. Now, as to the y values, we're doing two things. Remember that we've got an amplitude of 2, so what that would normally do for a cosine is that everything would pass through 2, 0, negative 2, 0, and 2, but remember that we're shifting everything up by 3, so we're going to add 3 to each and every y value that we had before. So our new cycle's y values here, going along with the amplitude, is going to be 5, 3, 1, 3, and then back up to 5. All right. Now the way I handle this is I say, well, it actually like as if we're taking our x-axis and shifting it upward by 3. So I'm just going to draw a dashed line there to represent that shift upward of 3. Our amplitude is 2, so we're actually going to have a graph whose highest points are 2 above and 2 below that central axis. So I actually just draw a dashed line to represent that. And now I go for my key points. And I know that my key points here are going to be at negative pi over 3, pi over 6, 2 pi over 3, 5 pi over 6, and then 5 pi over 3. Let's see, was that 5 pi? No, it was 7 pi over 6, not 5 pi over 6. Let's try that again here. Here we go. 7 pi over 6. Nice. All right, so what happens? Well, it's a cosine graph. We said that it's going to start at y equals 5. At pi over 6, we're going to pass through 3. At 2 pi over 3, we're going to pass through 1. 7 pi over 6, we're back to 3. And then 5 pi over 6, we're back up to 5. And then that cycle would start again. And our cycle, our one graph, oops, that should be right over here. I missed a little bit. Let's try that again. Our one cycle should look something like this, passing through each of our key points within one cycle. Here's one cycle, and maybe a little bit more, of our graph of y equals 2 cosine of the quantity x plus 3 plus 3. A couple quick notes. The domain of the function, as with all sine and cosine functions, unless we limit it specifically, is negative infinity to positive infinity. For the range, however, the range is easy to figure out. You're going to take our shift, our center axis, and subtract 2. So we took 3 minus 2, and that gives us 1. And then we're going to take our center axis 3 and shift it up 1, 3 plus 2. So our upper value of our range is 5. And so we're done. That's what we wanted.